Alrighty, so we're going to do a quick little video on how to do correlation between two series of data. I just made up some numbers right here. They're not related to anything in real life. I just made up ABC Co. and XYZ Inc. I gave some random stock prices that go back 11 periods actually, and then that gives us 10 rates of return that are based off of those data points. So it's literally just random numbers, but we're going to look at how these two correlate to each other. And so what we're looking for with correlation is if one stock, in this case, if one stock's returns are affecting another stock's returns. Do they constantly move together? Are they in lockstep, or do they maybe move inverse to each other? Correlation is going to vary between -1 and +1, and that's going to tell us if they move together or against each other, or maybe not related at all. So actually I'll put a little hint right here between -1, 0, and +1. And what that is if it's a -1, it's an inverse correlation. If it's 0, then there's no correlation. If it's +1, that's a positive correlation. Then that's telling us there we go. So that's telling us that if it's inverse, that means one stock going up will make the other one, well, it won't cause the other one to go down, but on average, if one stock is going up and the other one is going down at the same time, then that means their correlation is going to be negative. If they both go up together, then their correlation is going to be positive, and if they don't have any relation to each other at all, then their correlation is going to be 0. So let's go ahead and look at the correlation here. The function is correl, C-O-R-R-E-L. And all we have to do is highlight the two ranges. One key to make sure that you're aware of is you have to have the same amount of data. So you can't do a correlation like this, right? You'll get NA. And that's because you have a lot of data being correlated to a little data, and that doesn't work because they don't line up together. You can't do it that way. So you have to make sure you have the same amount. So you can't have well, both of these have 10 rates of return right here. That's 10 data points in each column, and that gives us a correlation of about 38%, 37 right there, 37.9%. I could actually just do that. There you go, 38% correlation. And so that's saying that these two stocks' returns move together 38% of the time. And so serial correlation is very similar. It's actually an offset, so what we'll do, I'll do correlation again, right, C-O-R-R-E-L, and then our array is actually going to be the same thing except for leave off the bottom value, and then compare it to the previous. So we have the most recent day, this 377 right here is the most recent day, versus yesterday's return of 7%. And so what that's saying is, how does XYZ today correlate to tomorrow ABC? And so we'll get some number, and that's 69. So that's a very large value because it's very close to +1. So that means that XYZ, and it's positive, which means they're positively correlated. That means XYZ Inc. going up yesterday would mean that we could probably do well betting that ABC will go up the next day, which is very interesting. You don't normally see that in the stock market, but I made up this data, so it's completely possible that I just happened to make up data points that fit a correlation. So what you would see, I'll give you another example here. If we had 1, 2, 3, 4, 5, and over here we had 5, 6, 7, 8, 9. So both of these series right here are going up by 1. They're not the same number, right? So it starts at 1 and goes up to 5, that one starts at 5 and goes up to 9. They're both going up by 1. But if we did the correlation between those two, you're going to get a correlation of 1, because both of those series are moving together in lockstep. And by plotting it on a chart, you can actually see that yourself. They move together. See that? So having those parallel means that one going up, the other one goes up at the same time. So that's what you would look for if you had a +1 correlation. Let's say we did 9, 8, 7, 6, 5. Well, now we have -1. And you can see that again if we plot it. We get an inverse. So when one goes up and the other goes down. So that's all that we're saying there with that correlation. So keys to look for, important points. make sure you have the same amount of data. If you have 10 points in one, you need 10 points in the other. If you have 1,000,000 points in one, you need 1,000,000 points in the other. So that you can't do a correlation between 5 and 30. You have to have the same amount, the same quantity of data points. And in serial correlation, that's how does one affect the price of the next. Actually, just for interest, let's flip it. So before we said that there was something like a 69% correlation between XYZ in the past and ABC in the future. Let's see what it is if we flip it. So what does ABC help us to predict XYZ in any way? So that's a 26% standard deviation, which is not as high. It's still pretty high, but it's definitely much less than the 69 or 60 something that we got before, the 69% that we got before. So XYZ is a much better indicator of the future of ABC than ABC is of the future of XYZ. Make sure that you understand the properties of correlation and how they work. But if you have any questions or anything, if this is confusing at all, send me a message. I'd be more than happy to help walk you through it. I hope this helps you for your lab, and good luck, and thanks for watching.